Now this section, section 2.4, is just a little bit more on slope. So we talked about slope in the previous section, but I guess just there are a few things that we didn't quite talk about that I guess we didn't want to throw in the previous section because it would be too muddled. And this section is nice and short, which is not, you don't see that too often in this book anyway. So we gotta enjoy it while we can. Alright, section 2.4 literally is titled More on Slope. They weren't very creative on that one, huh? Let's see, what are we talking about here? Many quantities, such as the number of men and the number of women living alone, are increasing over time. We can use slope to indicate how fast such quantities are growing on average. Alright, fair enough. If the slopes are the same, the quantities are growing at the same rate. However, if the slopes are different, then one quantity is growing faster than the other. That makes sense, I guess, right? If you saw two lines that had the same slope, they should be kind of growing or I guess declining too at the same rate. There were, let's see, 11.2 million men and 15.5 million women living alone in 2000. Since then, the number of men living alone has increased faster than the number of women living alone. If this trend continues, eventually the number of men living alone will catch up to the number of women living alone. That's kind of interesting. Okay. Alright, so I guess that's what they're saying. That's kind of the intro. They're saying, okay, this is where this could be possibly useful if you stop caring about these problems in the middle. Let's see. First, they want us to write an equation of the line passing through this point. Okay, that sounds kind of familiar, like we've seen it in the previous sections. But they want it to be parallel to the line whose equation is y equals 3x plus 1. So that's a little different. I think before, in the previous section, they gave us a point and the slope, and they said find the equation. Or they gave us 2 points and they said find the equation. But the key here is that if they're parallel lines like they're asking about, then they have the exact same slope. So the line I'm interested in, the line I want, I guess, the line I want should, and you don't have to write this down, this is just, if this helps or you've never seen this before and it's brand new, should have slope, well, I should say, have the same slope as the line given, which was y equals 3x plus 1. Now looking at that guy, we know by now the y-intercept is 1 and the slope is 3. So that means that I'd like my slope to be 3 because I want it to be the same as the line that I was given, and that guy's slope is 3. So it all comes down to, that was just a very complicated, convoluted way of them saying, find the equation of the line, equation of the line with slope 3. I had to kind of really think about what that slope would be looking at that line and going through the point given, which I think was -2, 5. Is that what they said? Yeah, I think it was. Alright. So it was just, the only new thing here is trying to figure out what's going on with parallel lines, but now that we have the point and the slope, we can use the point-slope formula to figure it out. So a lot of it's just kind of the similar thing to what we did in the previous section. It's just the parallel, and we'll see again pretty soon perpendicular lines. What are they all about? How do their slopes compare and all that? Let's see, the x1 and y1, here they are. -2 is x1, 5 is y1, so y1 is 5 and x1 is -2. The slope was 3 because we found out it was parallel to the original line that I was given, and that line had a slope 3. And now, like we've seen before, it's just a matter of simplifying this, making it look prettier. Y minus 5 equals, if I distribute the 3, well, first it's 3 times x plus 2 if I simplify it. So I can distribute the 3, making it 3x plus 6. And then the last step would be to move the 5 over. Alright, that looks good. Y equals 3x plus 11. There we go. That's a good guy. And if you're watching this video pretty soon after the previous one, if you wonder why at the end we're not replacing y with f of x, I mean, we could if you wanted to, but it's just, they didn't ask us to, so I don't really feel the need to. But in the previous problem that we saw the very last problem in the previous video, they said, call this a function e of x, so that's kind of what I had to do in the end. Let's see, now they're going to try to flip the script on us. They said, so it sounds similar at the beginning anyway, it says, write an equation of the line passing through, and then here's a point, but now it's perpendicular to a line, blah 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 blah. express the equation in point slope form, which just means they want y by itself, which we're probably going to do anyway. But then and in general form. So they want it to be in the same form that this guy's in, where all the values are on the same side. Gotta try to remember that. I might forget to do that. But then they tell us more about perpendicular lines. Well, visually, perpendicular lines, they meet at a 90-degree angle, so it's like they cross at a perfect 90-degree angle there. But how do their slopes compare? Because we saw that in the previous problem, that lines that are parallel have the same slope, exactly the same. But perpendicular lines should not have the same slope. I think first thing I can notice is when I draw this picture here with two perpendicular lines, one of them has positive slope and one of them has negative slope. So that's true. Perpendicular lines should have opposite signs for their slopes. But not only that, it says their slopes are reciprocals and have opposite signs. So one example of that would be if one line had slope negative 4/7, the other one would have slope positive 7/4. So not only are they're kind of opposites in two different ways. They're opposites in their signs. One's positive, one's negative. But also they're reciprocals of each other, which means I flip the fraction upside down. 4/7 becomes 7/4. So that kind of will help. Let me see. So we're going to try to do the same thing we did in the previous problem. But the previous problem, it took the equation of the line we were given, this guy. Well, it was a different equation in the previous problem, but we're taking this and we're trying to find the slope. That's my goal here, is I'm going to find this guy's slope. It's not obvious right now because it's not in the y equals mx plus b form. Find slope, then, I want to find the slope of the perpendicular line to it, so I'll have to change its sign. Because it has to be one positive and one negative, and find its reciprocal. So that'll give me the slope I want. Alright, I have to do a little more work here because the other one, the equation had the slope kind of sitting right in front of us, but this one I have to actually get y by itself, and then I'll be able to find the slope. Well, let's see, I don't think, we're going to need a lot of room on this problem. I'm going to try to write smaller. Let's see, I'll subtract the x over to move it, and I'll add the 12 over to move it. And then we'll see where we're at. We have 3y equals, and then negative x plus 12 is now on the right side. And then to get y by itself completely, I'm going to now divide by 3 every term individually. There we go. Now y is by itself. Looks like, if I want to extract the slope would be negative 1/3 times x. Because there is a 3 in the denominator, and then kind of like a negative 1 as a coefficient of x. And then 12 over 3 is 4. Not that that part matters, because remember what we're doing here is we're trying to look at this line's equation and figure out what its slope is. So this line has slope negative 1/3. But the line I want, and of course when you're doing this problem like on an exam or something, you don't have to write all this reasoning out. This is kind of what's going on in my brain. This line has slope negative 1/3. The line I want, or the one I'm supposed to find, should have opposite slope. Opposite slope. So first of all, I'll change the sign. This guy's, let's see which guy. This guy, come on. This guy's slope was negative. So I want to make it positive. If that guy's slope was positive, I'd make mine negative. I just want the opposite. So it's positive, but then also the reciprocal of that. The reciprocal of 1/3 should be 3 over 1. I just flip it upside down. But then, thankfully, that actually simplifies to just positive 3, because 3 over 1 is 3. That's kind of how you want to approach these problems, is figure out the slope of the line given. If they want the perpendicular line, take the slope of the line given, flip it upside down and change its sign, and then you'll have what you want. So okay, I'm starting with a slope of 3, all that just to say, I want my slope to be 3. And then after all that work, I forgot what I was doing. It's like, I wanted to take that slope, and the point given, I think there was a point given, here he is, negative 2, negative 6, and I want to take that point, and the slope I was given, and try to find the equation of that line. So, the line given was, what was he? The x plus 3y minus 12 equals 0. That's not really that important. It's actually not important at all in and of itself. All I wanted was to find his slope so that I could find the opposite of that for my slope. But now I don't need it anymore. That's all it was really there for. So now I have all I need, the slope and then the point. Y minus y1 equals m times x minus x1. Alright, if I substitute those in, x1 is -2, y1 is -6, then I should have what I need. Y minus blah 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 equals m, which is, we'll fill that in, times x minus blah blah blah. Okay. Let's see, y1 was -6, x1 was -2, and then the slope was 3. We'll fill that in. Alright. And let me simplify this. This is y plus 6 equals 3 times x plus 2. And then I guess I can distribute the 3. Let's see, that'll make it 3x plus 6. And now if I move this 6 over to get y by itself, that should be the end of the problem. Took forever, huh? Y equals, and since the 6 and the -6 cancel, this is just my answer. Y equals 3x. That just means there is no y-intercept, which means it'll go right through the origin. So not that they asked us to graph it, but if they wanted us to graph it, the y-intercept would be the origin, because I wouldn't have to go up or down at all. But then I'd rise 3 and run 1. So it would look like that. There's, you know, the line I was given, and maybe just for fun, the perpendicular line, what was the line they gave us? Oh yeah, well when I solved it and I got y by itself, it looked like this. The y-intercept was 4 and the slope was -1/3. Let's see how that looks. Y-intercept 4, this is just for fun. 1, 2, 3, 4, okay, here we go. And the slope was -1/3, so I go down 1, and then I'm running 3, which is positive, so I'll go right. Down 1, right 3. It's like that. You know what, I guess, those kind of, I mean, I didn't draw it perfectly, but I guess those look like perpendicular lines, you know, they kind of meet at a 90-degree angle. If they don't look like they're meeting at a 90-degree angle, it's probably because I didn't draw it very well. Alright. So that sounds good. Okay, now we're given another one of these fun ones where we have a real-life situation. But we're kind of well-versed in that by this point, I think, from the previous section. Let's see, what do they say here? In the year 2000, there were 11.2 million men living alone, and in 2013, so 13 years later, there were 15.0 million men living alone. So use the ordered pairs. Okay, at least they gave us the ordered pairs. That's nice. Use the ordered pairs to find the slope of the line through the points. And they want us to express the slope correct to 2 decimal places and describe what it represents. Okay, so I think we actually did that in the last couple problems of the previous lecture video, but we didn't really think about what the slope represented. I think that's the only kind of new thing here. And in the last couple problems in the previous lecture video, we didn't even think about, we did more work because we actually had to find the equation of the line. Here they're asking for less, they just want the slope, but they actually want to know what it represents. Okay, so, you know, you're writing it as change in y over change in x, but you could still use y2 minus y1 over x2 minus x1, and you can just call these guys, here's x1, y1, here's x2, y2, and then you're filling those into the slope formula. They did it here for us, which is nice. So 15.0 was y2, 11.2 was y1, 2013 was x2, 2000 was x1, and when you subtract the numerators you get 3.8, when you subtract the denominators you get 13, and if you divide those in your calculator, 3.8 divided by 13, it should, you know, it probably has a decimal that goes on a while, but they said round it to 2 decimal places, so it looks like it's going to be 0.29. There we go. So then they want us to interpret that. That's actually one of the harder things I think to do in math is if you have a real life situation and you're doing, you know, you're doing some kind of mathematical operation with it, figuring out what the heck that represents in real life is one of the harder things. I mean, that's my opinion. But that would be, the interpretation would be the number of men living alone increases at an average rate of approximately 0.29 men per year. So that, they came up with that because, let's see, when I get my slope, let's see, just to kind of write a little more out here. When I got my slope, you can think of any number as over 1, which I think it'll help you interpret it, because you're always thinking of slope as rise over run, or change in y, like they said, over change in x. So I think if you come across these problems where they say, interpret the slope, what does it mean in real life, and you're kind of having a hard time, it's a good idea to think of it that way. Put the number, whatever it is, as a decimal over 1, and then think of it as change in y over change in x, and then think about what was y and what was x. I already forgot. The y values were 11.2 and 15.0. That was the number of, the number of millions of men living alone? Is that right? Yeah. Number of millions Is that how you say it? I don't know. Of men living alone. And the change in x was the number of years that passed. Number of years passed. So if I kind of match those up, you know, numerator to numerator, denominator to denominator, 0.29 was the number of million men living alone, okay, because that's the numerator of the slope. And then the denominator was 1, because, well, I divided it and made it a decimal. 1 year passed, and 0.29 million men living alone. And then I guess the last kind of, well, it seems like a small part, but it's actually important, is notice the slope, it doesn't have a positive next to it, but that's a positive number, 0.29. So if the slope is positive, that means a quantity is increasing. So that's kind of helpful, especially if you're trying to interpret the slope. Positive slope, that means that a quantity increases. Whatever you're talking about, in this case it's the number of people living alone. But if the slope came out negative, like in a different problem maybe, then that would mean that the quantity you're measuring, in this case the number of men living alone, would be decreasing. So you definitely want to mention increase or decrease in your answer. Quantity is decreasing. So I guess all that just kind of decodes how they figured out what the interpretation was. The number of men living alone increased. Okay, increased because it's a positive slope. Slope, okay, I knew that. That's the key word. At an average rate of approximately 0.29, that was our numerator here. And that represented, remember, the number of millions of men living alone per year. They only mentioned 1 year because the denominator was 1. And that represented the number of years that passed. So probably, yeah, I think of all the... Maybe it's just because I like math and English and stuff is not really my best subject. It's just like the interpretation is always the hardest part for me. Let's try that. Now we kind of have the training wheels off and now we're trying it on our own. Let's see. A different problem. It says, in 1994, 617 active duty service members were discharged under the Don't Ask, Don't Tell policy. In 1998, so 4 years later, 1,163 were discharged under the policy. So the quantity, probably I'm imagining the quantity we're measuring here is the number of people discharged. It's increasing, so I should expect a positive slope. This time, that's how many people were discharged under the policy. And they're very nice. They gave us the ordered pairs, x1 and y1, x2 and y2. To find the slope of the line passing through the points and then express the slope correct to the nearest whole number. Okay, I gotta remember that. That's where they want us to round it. And then describe what it represents. Okay, sounds good. Let's try it here. y2 minus y1 over x2 minus x1. Let's see. So I kind of labeled them up here somewhere. Let's see. Yeah, here's the x1 and the y1. Here's the x2 and the y2. Let's fill those guys in. Y2 we labeled for the 1,163. And then the y1 was 617. X2 was 1998. And x1 was 1994. Alright, well I can subtract the denominators in my head, but the numerator I might have to use a calculator. Don't judge me. I get 546. Okay, and we're supposed to divide those, and then once we divide them, we should get something, and we're going to round it to the nearest whole number. My calculator says it's it's exactly 136.5. But they want us to round that to the nearest whole number. The 5 would round the 6 up to a 7. So it's about 137 for the slope. Alright, now the decoding it is hard. Let me see. I gotta, I think the more you do this, the better you'll get at it. But you have to really reason it out. Let me see. So I got 137 for the slope. But I want to think of the slope as a fraction, just because I know it's change in y over change in x. In y, so that's the numerator. And then I gotta think about what y represents. This is the change in x. Okay, what was y? Oh, y was the number of service members discharged. Okay. Number of... And you don't have to write this out. This could be all in your head. Service members discharged. Okay. And then the x was the year, number of years. That passed, I guess. No, just year. Yeah, the year. Alright, and then this kind of, it seems like a small thing, but it actually becomes a big thing. This is a positive slope, so that means something's increasing. And whatever is increasing is the y value. The change in y was the number of service members. Okay, so that means there were or there was, that's a better way to say it, there was an increase of 137 I don't know how you can phrase it all kinds of ways, but I'll say discharged service members per year from, you know, the years they were talking about. I already forgot what years they were. 1998 and 1994. 1994 to 1998. Alright, that's a fine answer, but I think technically I should put an extra word in there. There was I should put here between and increase average. So that's because I think what I found was 137. That would be if every year the exact same number of people increased, you know, but it might be between, say, 1994 and 1995, there was a big jump and a lot of people, a lot more people were just discharged, and then maybe the following year a little bit less. So I guess you don't really know if it was every single year they were exactly 137. It's just kind of like it averaged out to be 137 per year. So it's probably more correct. I'd probably, if I didn't see the word average, I wouldn't mark anybody down points, but just to be safe, because we don't really know exactly all the numbers. I don't know how many people were discharged every single year between 1994 and 1998, so I can't really say it was exactly 137. Ugh, so those are tough. I always thought, but maybe you don't think they're that tough. I think they are. All right, then the final objective here is, this is another thing that was kind of like, what was it called? Remember the difference quotient a few sections back? It was like, this is a lot like, I think the formula was f of x plus h minus f of x over h. Remember, and we had to keep calculating what that was for different functions. So that's how this one's gonna work too. Yeah, it's not pretty, but it's similar. It's a similar formula, and it's the same thing as last time. It's useful in calculus, but right now we don't really see why or whatever. So the average rate of change. All right, it's kind of like they're just throwing in a new formula for us, and we have to fill things in. So here, notice in the first example, here's the function. So that's kind of what we're gonna do here. That's the f of x, but they're giving us x1 is -2, and x2 is 1. So it's up to you. If you feel comfortable, you can just plug everything in this formula right now. Or you can kind of go step by step. Like first you could figure out the parts of it. So I noticed the top left part of the formula has an f of x2. I can figure out what that is. Because x2 is this value 1. And then f of x is x cubed. That was the function given. So pretty much you're plugging in, or substituting, whatever, plugging in x2 equals 1 into f of x equals x cubed is just the first part of that formula. So okay, let me see, just to make it more clear, hopefully I'm going to use the value that I'm plugging in. I'll put it as a different color. So I mean 1 cubed, 1 to the third power is just 1. So that is the value that's going to go right here, f of x2. And now maybe I'll figure out what f of x1 is, because that's the next part of the formula. They want f of x1. It's very similar, it's just I'm plugging in a different value, because they told me that x1 is -2. So I'm going to substitute that into x cubed. I should say substitute, not plug in. That's more correct. Substitute x equals -2, or x1, sorry, x1 equals -2 into the function that was given. That's pretty much what's going on here. So okay, the value I want to plug in is -2. I'm substituting that in. Substitute it in and you get -2 to the third power. That's -2 times -2 times -2. That's 3 negatives. It'll make a negative. 2 times 2 times 2 is 8. So that'll go here. Alright. So I think we're ready to plug everything in. I'm just going to now rewrite the formula so I have it down at this really low level. It's f of x2 minus f of x1 over x2 minus x1. And then if you want, it's kind of nice if you have time or you're more organized, I guess, you can gather your thoughts over here. What did they give us? x1 and x2 were what now? They were -2 and 1. And then we just found in the first little part here, f of x2 we just found to be 1, and f of x1 was -8. So those are the 4 quantities that we're going to be plugging in here. It's kind of nice to just have them sitting next to you so you don't have to really think about it. So first, f of x2, what was that guy? He is here, that's 1. And then f of x1 was -8. Let me plug that in. And then x2 is 1. I'll plug that in, and then x1 goes here, that's -2. Ugh. So kind of a lot to keep track of, you know. It's one of those things this is difficult conceptually, but like I said, it'll be useful later. So this numerator, if I simplify it, it becomes 1 plus 8, and similarly in the denominator, 1 plus 2. So it looks like 9 over 3, which simplifies to 3. Alright, so our answer is 3, which, you know, right now we don't really know what the heck that stands for. But it's, I don't know. If you care, you'll see it again in calculus, but what it really stands for is this function f of x equals x cubed. If I were to graph that guy, let me see, I'm going to try to graph kind of a rough sketch here. This is if you care. If you don't care, you can always fast forward this part. But you'll see this guy again later. They're saying from the x values that were given were what? x1 equals -2 and x2 equals 1. So between those two x values, let's say -2 and here's 1. So from here to here on the graph, the average slope is what we found, 3. That's actually pretty impressive, because if I were to take any point in between those two values, like any point on the graph in this green area, that's infinitely many points. If I were to find all those slopes, all the slopes in there, all the infinitely many slopes, and average them all out, I would get 3. It's pretty, right? That's pretty impressive, I think. And it probably doesn't look like it from my graph, because I don't graph. That's not the prettiest graph in the world, but if you actually saw the graph, the real perfect one that a computer could generate, then you'd probably see it easier. Alright, so probably no one out there cares about that, but I said it anyway. Alright, now we want to do the same thing. We have f of x equals 3x, and now our first x value is x1 equals 0, and x2 equals 5. So it's up to you. If you feel comfortable, you can just start jumping into the average rate of change formula, f of x2 minus f of x1 over x2 minus x1, but it's kind of nice to just do it in stages, you know, 1 step, 2 steps, and then plug it all in. So I think the first step I would do is, like we said, substitute, say, x1 into f, or x2, whatever, f of x2, because that's the first thing that the formula calls for. And f of x is 3x, so it'll be 3 times x. Wait, I think I'm kind of jumping the gun here. Let me erase that a little bit. 1 step at a time here, right? F of x2, but x2 was 5. So I'm going to try to substitute 5 into this guy. That would be 3 times 5. And that should be it. Let's see. So 15, okay. Now I know. Maybe I can gather that information down here. F of x2 is 15. Or you can just kind of throw that in right here. This guy is 15. Now I know that. Alright, now we want to find f of x1. And then I think we're pretty much ready to plug everything in the difference quotient. Sorry. The average rate of change formula. x1 was, let's see, 0. So on f of 0, and f is 3 times x, so I'll just be replacing x with 0. But 3 times 0, of course, is 0. So it looks like f of x1 is 0. Alright, I think we got all the parts we need for this little formula here. We got... And then x2 and x1 were what now? x2 was 5, and x1 was 0. There we go, and we'll just fill all those things in. 15, and then minus, let's see, f of x1 was who? Oh, 0, okay. Might as well use the same colors, huh, so I don't confuse myself. Over x2 was... We got 5, and x1 was 0. That's kind of a nice answer. 15 minus 0 is 15. 5 minus 0 is 5. So it ends up being 15 over 5, which is 3. Come on. Same answer as before? Are you serious? That's kind of boring. Alright. But you know what? That one, I know it's going to make you mad if I tell you now, but that one I feel like I should have guessed. Because look at this function. If I replace f of x with y, it's y equals 3x. That's a line, and it has slope 3. And this is asking for the average rate of change, which is the same as the average slope. But a line is kind of one of the most boring functions because it always has the same slope no matter where you are. So if you have a line and they're asking you for the average rate of change, the answer is always going to be the slope of that line, you know? In this case, 3. It doesn't matter what x1 and y1 are. Or sorry, it doesn't matter what x1 and x2 are because the slope should be the same no matter what. So yeah, kind of a silly problem, but it's good practice, right? Good practice. That's kind of the main thing here. I guess we don't really care about the answers to these, we just want to practice for when we actually do care about the answers to these. Alright, we got a couple more problems here just to get a good idea of what's going on. But it's the same stuff, it's just new functions and new x1 and y1 values. So we'll kind of do the same thing here. First, I'm going to try to find the first part of the formula f of x2. So they said x2 is 9, so I want f of 9. And the function itself is the square root of x, which is kind of interesting. So I want the square root of 9, which is 3. Alright. So maybe I'll write that down here, because that'll help us when we use the formula. F of x2 is 3. Gotcha. Now the next thing I want to do is now find f of x1, the other value. And you know, I'm finding f of x2 first and then f of x1, but it doesn't really matter. You can do it in either order, right? It doesn't matter. But x1 is 4. And the function itself is the square root, so I'm taking the square root of that number, which is 4, and that'll be 2. So okay, I might as well bring that down for when I need it. F of x1 is 2. Alright, now that I know those kind of more complicated parts to the formula, I'm going to go ahead and write it out. It's f of x2 minus f of x1 over x2 minus x1. There you go, and then I'll fill in what I know. Let's see, I'm going to just write it out here. Let's see, f of x2 was 3, so that'll go at the top left. And then f of x1 was 2, that'll go here. And then I kind of remember, I think, x2 was 9 and x1 was 4. So those will go here, 9 and 4. And let's see, what is that? 1 over 5. Huh, so the average slope of the graph of the square root of x. So if you were to graph the square root of x, which if you give a crap, I doubt it, but hey, I just threw it anyway. He looks like this. He kind of looks like a little rocket taking off or something in the sideways direction. So if you were to go from x equals 4, which say is right here maybe, and then x equals 9, which is maybe here, you know, the average slope between all those points that are in between those x values is 1/4. Or sorry, 1/5. It's not really a very large slope. That's kind of how this graph is. It kind of tapers off. The slope is getting smaller and smaller. Okay, let's try this last one, and I think we have the hang of it after that. So I'll kind of do the same thing. I'm going to first find f of x2, and then x2 in this case was 5. But the function itself is kind of more interesting. It's x squared plus 2x. So that's two places to put your x value. In this case, the x value I want is 5. Let me try to simplify that guy. That'll be 25 plus 10, so 35. Alright, I might write that down below. F of x2 is 35, just so I keep track of everything I find. And then the next thing I want to do is find f of x1, and the value of x1 they told us was 3. Okay, so I want f of 3. And the function itself is x squared plus 2x. But in this case, the x I want is 3. I'm going to put a 3 where those x's were. And I think that should do it, as long as I'm careful. This is 9 plus 6, which is 15. Looks like f of x1 is 15. There we go. Now I think we're ready to kind of put it all together in the average rate of change formula. And I already forgot what x2 and x1 were. They were 5 and 3, huh? 5? Okay. Now the last step is just to fill it all in. The formula is f of x2 minus f of x1 over x2 minus x1. Let's see, f of x2 is 35. We'll fill that guy in. Let's see, where are we? 35. And then f of x1 was 15. We'll fill that guy in. And then let's see, x2 and x1 were 5 and 3 respectively. Make sure you don't mix those up, because that would make this a negative, change the sign. In the numerator, those subtract to make 20. And the denominator, you get 2, which now that's a nice whole number, huh? 10. Yeah, that's not bad. Beautiful. Alright. That's an interesting one. So, yeah, that one's not... I guess it doesn't seem as useful right now, but like I said, in calculus that'll be important. And it'll help. Having seen it now will help a lot. So, okay. I promised a shorter video, and I think that's it. So, thank you for listening. I'll talk to you in the next one.